All right, so as I mentioned earlier, oftentimes your query goes beyond what the boilerplate queries you might have, like find all, find by ID, save or whatever. So those are the boilerplate implementations of the repository. If you want to implement your own, you have to provide an API for it. Right? Typically, you would create a DAO. Right? Inside of the DAO, you would create the query. Here's a little bit easier. You just have to provide the signature, the interface of how you want your function to be called. Right? And then associate with that function, associate a query that goes along with it. This is the SQL that I would want to execute, right, that goes along with that particular query. So for instance, we might want in our repository, we might want the following. So in the repository, we might want functions such as a public user find user by username, and I provide a string username, for instance, right? That would make sense, right? I'd like to retrieve you. If I want to register somebody, I want to make sure to see if that username is already taken. Right? So that's a very common query. The other one, if somebody's logging in, perhaps I would want something like user find a user by credentials, and I would provide username and password. Right? So those are the queries of how I would want to use them, right? But I don't want to have to implement this, right? How annoying would that be? Instead, what we can do is declare them as queries and say, hey, these are the queries that I would want you to use to talk to the database, right? And we declare on top of it, we say these are the queries that are associated to these two functions, to these two methods, right? And query is, there it is, JPA repository query. And in here, we can provide a string. The string is an SQL query, but it's not any SQL query, although it will look very much like an SQL query. It's an object-oriented SQL query. Right? It's aware of the names of the classes. It's aware of the names of the fields in those classes. It's not necessarily aware of the tables and the fields in the relational database. Right? That mapping is done by JPA. So this allows you to do the queries a little bit higher level. Right? So instead of doing the joins like you would normally do in a relational database, where you do queries where this primary key is equal to this foreign key, that's way too low level. Right? Instead, in Java, the way you navigate between classes or between objects is through the getter methods, right? Or through the dot notation. You would start off at a parent dot child dot child dot child, right? Which that has to be converted into a join, a 3 or 4-way join, right? Where the primary keys of each tuple of tables would have to be joined in the primary and foreign key. So these queries allow you to stay at a high level on an object-oriented world. Although you can, if you want, use native queries, right? If you know exactly the query that you want underneath that you're using at your relational database, and you've done it at the command line, and you know exactly the query, you can also paste that here. But then you have to explicitly say that this is a native query, not a high-level query. Anyway, let's use the high-level queries. Here we want something like select user from user, where user.username is equal to some placeholder username. So notice the syntax here, right? Notice that from user, that user there is not referring to the table user. It's referring to the class user. Okay? And that user.username is not table user.field username, is referring to the object user from the class user, right? Dot username as a property of the class. Make sense? All right, so this navigation here, these fields and these tables are actually classes and properties of those classes. Make sense? But an attempt was made to keep it to look very much like a make it look like SQL as possible. Okay. Similarly, the query for the find by credentials will look something similar. You would find where username equals username, and the user dot password is equal to password. That. Something like that. Make sense? All right. So now these values here, notice that the colon in front of them. See that? Colon? That's a placeholder. Right? Just like a prepared statement, you have question marks that you can then fill in the blanks. This one too. These values, colon username, is a placeholder. Somehow we would like them to map to the string that is the argument, the parameter of that function, of that method. Right? And so to do that, there's also annotations for that as well. We can annotate this. We can annotate this as a parameter. We can annotate this string, right, as a parameter. Load param. And tell it what does it map to. This string, this username string, is going to map to the field username over here, right? This placeholder username. And these two here, username and password, are going to map to the other fields. Right? So this is param username and param password. All right. Okay. I think we're set. Let's play around with this. Let's see if we can retrieve some users using this repository. Let's go back to our test user, and let's create a test for each one of these. We can say maybe I already have it written here. We did that. Okay, let's copy this here. Test find user by username. Let's try that. Let's grab a hold, not Alice. We already have Alice, so let's try Bob. Try to find Bob and print the first name. And let's try out the next one by credentials. Let's grab this here. And let's try out maybe Charlie. Right, find user by credentials. This is, we already did Bob. Let's do Charlie here. So Charlie and Charlie. All right, let's try it out. Let's run these. All right, there it is. So we have Charlie, Bob. They're a little bit out of order, but nevertheless, those are the other two that we hadn't tried out. Everybody okay? Make sense? All right, excellent.